if it was there was no water, if there was no water, it should have burnt. But now you can see it is not easy.
No, but I have something here. And I want you to touch this and this, and tell me.
A substance, a dry cell which is hot, and as the material is given.
This is a conductor.
Okay, we have another experimentation. Okay? Here we have two oranges, okay? One is filled, you have seen it was filled by your colleague here. And we can do it now, it's okay? Just do what we think, we think. Yes, we start by
This is a hot water.
Yeah.
And those here adding hot water. Can you bring this? Here we go. We have a case of a cup of the hot water and a tipper. We are going to use the two sides because we don't have enough cups. Okay?
Why do we need practical work in class? How do we need to conduct practical work in class? Why do we need to conduct the experiment? Yes. Okay.
They can use their apparatus in every
We don't want to teach people in theory. This is practice. To connect the theory to the reality. But the one which is making this burning, he really can make it. But he has explained a little bit much more deep, saying that this experiment is the one which is teaching people or teachers, but you have always to show such kind of experiment.
University of Rwanda College of Education lecturers who are involved in the training of O-level teachers of mathematics and science on innovative teaching methods have demonstrated how it is easy and interesting to carry out experiments in mathematics and science classes using very usual objects or available resources without laboratory. They organized for the trainees a series of practical experiments, urging them to leave out the habit of teaching mathematics and science in theory only. The facilitators indicated that learners had to undertake open investigations in the form of both hands-on and minds-on activities for being interested in mathematics and science classes, deepening mathematics and science understanding, as well as developing related skills necessary in their lives. According to them, well-planned and used demonstrations in mathematics and science classes provoke natural curiosity of learners. Learners connect easily with the concept to be taught and grasp it, get excited, stay engaged, and feel that they are truly learning. Trainees were shown how they can engage learners or excite them through discrepant events. As shown in the following clips, a teacher may demonstrate a puzzling or discrepant phenomenon, define a challenging problem, tell about a special event, show a puzzling picture or video, etc. As observed, the teacher activates prior knowledge of the learners, stimulates them to observe and to formulate interesting questions.
No, but I have something here. And I want you to touch this and tell me your observation. Okay? Touch both at the same time. What is your observation?
One is a single, is very hard, and other is soft.
Hard. Okay, hard.
Hard and soft.
Another one.
One to touch.
Another one who want to touch.
Electric, of course.
Elite, please, madam. Try to touch and touch this. No, touch. Touch something is to do like this. What do you observe?
The same.
Are not the same. In terms of what?
In terms of what is answered.
Are you sure? Density, please. Try. The feeling.
I think I the same, but inside they contain different things inside.
What about temperature and heat? Or heat?
One is
Which one is what?
Which one is it hot?
Can you share
Are you sure?
yeah, I'm sure. Because I'm feeling it. Not changing temperature.
I didn't say.
Yeah.
Very English, but there is no change.
Okay.
Who can predict the cause of hotness?
Can you predict?
Can you predict? What is the cause?
Yeah, this one contains maybe the cell.
Yes.
Maybe.
Let me open and see. This is hot or cold?
This is all.
Is it hot? This one is cold. Let us open and see what is inside. Open this. This is hot. Open it. Nothing. But here, there is something. What is this? And who can explain this? Why this was hot? Why this is cold? Why? Yes, please.
That one is cold because it contains a substance, a dry cell which is hot, and as the material is given.
This is a conductor,
Yes.
and this is not hot.
This is hot.
Before it was not it was cold.
So this is a good conductor of electricity. So this is negative charge, positive charge, and this cause effect of heating effect. The interaction between positive charge and negative charge produce heat.
Enfin, we need to explain this by using concept of physics. As as you know, we can define what we call electricity. Electricity, it is a motion of electron on charges. Then when charges or ion are moving inside a conductor, we have what we call electricity. And if the conductor is heated up, that phenomena is called Joule effect. Yeah, here we have the source of electricity, the battery. Then if we put the battery inside, we make electric circuit. How? Yes. I need a marker. Yes. I can show you. Let us consider this is the battery. Here we have negative, here we have positive. And we connect a conductor. This is it, a good conductor of electricity, aluminium. Yes? Then charge will move from positive to negative, like this. This is we have electric current. Then when electric current passes through any conductor, then the conductor is heated up. This phenomena is called the Joule effect. It is what we have observed from this one. Yes? Someone can give an example or where we can observe this phenomena in the real life? Iron? Kettle? Try to find an example here in the classroom. Yes. When the computer is connected on the power, here we can feel a heat here or on the projector also. This is a phenomenon of Joule effect. Thank you so much.
Okay, we have another discrete event. Okay? Here we have two oranges, okay? One is filled, you have seen it was filled by your colleague here. We're gonna put water here, it's okay? Can you finish with the water? But before doing anything, put enough water, yes. Yes, continue. Okay. So you have the two oranges. One is filled, another one is not filled. Okay? Which one will sink once you put them in water? Yeah. Which one may sink? May sink. Why? You can predict and say why. Which one will sink? So you can write here the two the possible answers we are providing. So the period, let's say the period will sink. B, another period will sink. So we have two options. It's okay? You will choose if the field will sink, if both may sink. Both will sink. Or both will float. Yes, good. Both will float. Okay, now we're going to vote. It's okay? So, those who think that they're in A, those who vote for A, can you raise your hands? How many? How many? Okay, how many can you count? 11. Okay, non-filled will sink. How many? Okay? Two. Non-period will sing. Then both will sing. No one? Now, please find the category which you can. Both will sing.
One. We have one.
Okay, the last one, both will float. One.
The period will sink, but and period will float.
Okay, the period will sink. Okay, like you are here? Like you are in the edge. Okay, let's do the. You should also predict and give the reasons why you think it would be like that. So in group one, you can choose one person to tell us why do you think that the period will sink.
The first one, the period one will sink because that cover, when you reduce the volume, the density will increase.
The density will increase.
That's why.
Why do you think the density will increase? Because you are removing the cover, of course, it's going with the mass and the volume.
No, in the cover, there is some volume, empty space.
Yes, empty space.
That will make the unpaired one to have a big volume.
Maybe, but we don't know. Let's see from others.
I have not a glow of pen because
Yeah.
if we remove the cover, we reduce also the mass.
Yes.
We reduce the volume, but also the mass is decreasing. Yes. Yeah. If
Yes.
it's the gas, there is no change on the density.
Yes, your idea? What's from the group, first group?
Yes, I supported him
Yes.
because the volume that we have removed, it has a small mass compared to the volume which you have.
Maybe we need to take a balance to be sure.
Yes.
Okay?
I think that orange has its mass.
It's mass.
Yeah, and we know mass is equal to density times volume. So the orange has no, it is the same, but when the volume reduces, the density is increasing.
The volume is reducing this.
Yes, of course. If the mass of orange is equal to density times volume,
yes,
and you reduce the volume, means the density will raise.
You reduce also the mass. And the density here, remember that you have the field there, and the inner of the orange, their density also are different. Are they the same? Are you the group one of you?
Yeah, the
yes.
one. The period one will faint because after removing the cover, it will be able to absorb the water.
That's another idea. There is absorption of water within them, but we are not. Let's see from the group two. Then we take the conclusion later. Group two. Why do you think that non-period will sink? Non-period will sink.
The molecular of non-period orange is remaining constant.
The molecules?
Yeah.
Molecules in non-period is constant.
Remaining constant.
Constant, what do you mean?
Mass of
the mass, yes.
Remaining constant.
Of course, yes, the mass will remain constant because we have removed nothing. But this one also, it has its own mass and its volume. So we need to know which one may, when you compare both, why do you think this one will sink? Why the period one will not sink?
Both have the same mass.
Both will sink for you?
No.
This one will sink.
This because it must remain constant, but the mass of this one is reduced.
Okay, let's see, we will see. So the group which is in both will sink. One person. Both will sink. This one. Can you tell us how? Okay. The group which, okay, no one. Okay, let's see. We can do it now. It's okay? Just group what we think, we sink. Yes, we Respond by it.
At the same time.
Okay. You can put it at the same time. At the same time. You see what happens? Have you seen it? Okay, as you have understood the explanation for your body, you see that this is not the period one where it floats, okay? When the period one is sinking, as we see, water can even be diffused through the boundaries of this one, which is the period, okay? And this activity, what is already ready the discrepant events, okay? The discrepant events are the activities normally done during the exciting engaged phase. And they stimulate the attention of learners, okay? And they need the learners to understand the real context of science, okay? This time they will be able to understand that there is a problem of diffusion of the molecular charge of water which is coming within this period one, okay? And of course, we can think about also this the volume reduced comparing to the mass of the whole volume. Okay? So, where did we understand? Through the okay. Listen, can you please follow here? Can you? So, the discrepant events are the key events to excite and engage our learners. Have you seen it? Think what will happen in your class once you are showing an experiment like this one. It's okay? Once you are showing a demonstration like this one, it creates a conflict between the observation and the thinking models they are seeing or they have in their daily life. An example. Noel was thinking that if the light touches the bottom of the balloon, directly it should burst. It's okay? Because you know already the balloon, once it is in contact with the fire, it can burst directly. But it is quite different from what we were thinking. It's okay? As you see for this image, it shows that there is really the conflict between what he was saying and what he thinks should be the correct one. It's okay? So those discrepant events are really the key to excite or to engage your learners during your lessons, okay? Please apply them in your lessons. You will see how your learners will be motivated.
Yes.
Really?
Yeah.
Okay, that's good. So, going on, as you see on these images, it helps the learners to have this questioning in their mind. They can't miss your question to ask you, but it creates also this thinking how they can find the solution to those problems. At the end, once they discover, wow, they find the light in their mind. Now they've built the confidence to understand the science. They will always be able to explain the content, what they have discovered during the use of discrepant events in their answers. Are you together? So, from there, please use them just to motivate your learners, but remember that they are used also to generate the key question of the lesson. And you will use them during the excite engage phase. Are you together? Yes. So, here we have another activity. For you, what's the subject or a topic what you will teach soon? Try to find a discrepant event that you can use during the excite engage phase. How will you use it? How will it trigger the interest of learners? Because remember that the discrepant event may be specific for a given lesson, okay? Depending to what you want to teach. So you can think, can you work in groups? And you think about which type of discrepant event can I use to teach this topic of my lesson? Are you together? Can you do it? For example, this one you can teach once you are going to teach the diffusion, isn't it? To show that there is water which has migrated in a bit the orange. It's okay? When you want to teach density for physics, and the mathematics, I think also they can use maybe. It's okay? Depending to what you are going to teach in your subject. So, you can be working in your groups to to work on this content.
There is the effect of the glass of water, and also the right. Going to do it and see and tell me what you observe. Anything you observe? I think it depends depending on what we have here. Are you watching here? I'm not doing that. You can't touch. What do you observe? What do you observe? What do you have to do? Anyone can touch. What do you observe? There is production of heat. If you are trying to touch, there is production of heat. Showing you another example like how the electric circuit is passing through a good conductor of electricity. Are we together? And then, for biology and chemistry, we have another one is here. Another one is here. You can move there. This is a hot water. And those here adding hot water. Can you bring this? You have to mix everything together. It's also hot water. Okay? After that, we have one bag of tea bag. Okay? And now, do you know what you're going to do? You have a crest of a cup of the hot water and a tea bag. We are going to use the two sides because we don't have enough cups. Okay? You are going to sink the crest of the tea bag within the hot water. And tell me what you observe. Just make a tea. You see, there is material. So as you see here, the heat can affect diffusion. There is, what is diffusion?
Movement of particles
The movement of particles
from where they are
highly concentrated to where they are lower
concentration.
But when we put when you add the cold water, and then we are going to see our tipper. Anything you see like a change? Any change? No change. Even when we are doing like this, the very, very small doesn't change anything. You see?
It takes time.
It's take time, but it's very, very small. Why? How can I explain why? The temperature can increase the pace of the diffusion. As long as the water is too hot, it means that the capacity of the diffusion is also increased. This is what we call diffusion. And this is among the softest and the cheapest experiments you can conduct within your class. One of the cheapest experiments. Is this clear? Okay. What did you observe here? You observed? What do you observe? The color of water changed. Why the color changed?
The total students are in the class. All the rest the students attend the class for the rest.
Okay. Sometimes they ask you to ask to put the registered student and the student who are present. But in this case, you can put, if it is the class size, the class that you have. So you will put the students which are present. Because it is your real class size. Okay? Yes?
So I wanted to reflect on this lesson plan. There is an objective.
Yes?
Given material, students or learner able to find the volume of regular shape.
The students are not thinking more. Are not thinking more. Are not thinking more.
I'm not thinking more. Those questions in activity A are open questions. The reason why the students are not thinking more. Only the activity B is an inquiry based.
The activity B is
inquiry based.
Inquiry based
because the students are thinking more.
Because the students are thinking more.
No. Those questions are closed, are open. Questions.
But the one which is making this burning, he really can make it. But he has explained a little bit much more deep, saying that this experiment is the one which is teaching people or teachers, but you have always to show such kind of experiment which ask the student to think, to ask questions. What is this? What is this? And then why is it burning? And then you try they try to experiment and see effectively what is the reason. There is another one which is parallel to this. And scientifically, he said that if you are a scientist, you cannot tell that this is the water. The water is having its own properties. The boiling point, the freezing point. If you say it is the water, we have to go to the lab and show that it is water. Yeah. But otherwise, everything which is in color, it's not water. And that's why, if you touch, you touch inside the sea. You touch. You can see. You can see.
You see that.
You see, there are many things inside. But you are not seeing. So you have to be careful on what we are seeing. And if you say that this is water, it's not water. It's not water. Anyway, it's water, but it's something else. Isn't it? Now the students will be questioning, will be asking, what is this? Why this is not visible? Different questions. But when they have come to satisfy their curiosity, they will be curious. And they will be asking questions. And that's where science starts. Okay, so you can.
Yeah. These different experiments you can make may help learner to ask questions why this candle is burning and our teacher is eating it. How can a man can eat a candle? Now let me see if it is a candle. What this candle is made with? They will ask so many questions. Even when we talk about the key question in a class, key question, when we are in 5Ps. When we make a good experiment, like this one or another, students will ask so many questions. Why this? Why not this? What is making this to happen? And so on. And finally, you said to the teacher, now try to make all questions you asked in one question, which can combine all of those questions. And that one question will be a key question of the lesson. Do you understand how a question is made? With a curiosity from learners, asking many questions, we come up with one question which is a key question. And the many processes will be to answer to that key question. Now, here we have PPTs, we will not go there, but we will also try making different experiments. This one we finished with it. You see, till now, the water is up. This one I wanted to show you. We have a candle. This is a candle. For making sure it is a candle, you have to touch it. Okay. Now, maybe let us go to another experiment here. Here, I have, this one is orange. If I put this orange in water, here I can get water. Maybe chicken. We have water here. This is the water. And suppose you made the observation
making sure that it's the water, nothing else. And this unique observation is orange. For students making an experiment, you have to start by to ask to prompt what will happen. If I do this, what will happen? It means there will be those who will be for A, other for not A. And now you will ask for A, why A? The demonstration. Now you will ask to those who said B to observe well and to change to see what happened to not be happen. You understand?
Yeah.
Let us do that as you said. This is an orange. What will happen to it if I put it into the water? It will sink or float. It will sink or float. Those who are for sink, raise your hand. Those who are, this one will sink. Those who are for floating, raise your hand. Floating. There is also float. Anyone for float? The majority is saying it will float. And then for those who said it will sink, it will sink no more. Serious? And let us call this one. This is taking photo, maybe another one. You can come and put it this. To see whether it will sink or float. Floating, it means that we say that is floating. Yes. This is floating. Now, let us ask you a second question. If I remove the skin of the orange, I remove the skin. I remove the skin. It will sink or it will float more. It will float more. No, I said it will float more. For those, raise your hands. Only 1, 2. Float more means it will be like this. It will float more. I have 1, 2, 3. It will sink more. It means to the bottom. Like a half. It will sink, but after taking some water, it will float fast. And because the skin is removed, some water will enter and start to sink. Yes. Those who are at that ocean, raise your hands. Taking time to sink. To sink. It means you have three oceans. It will sink immediately. It will sink after a certain time. It will float. Sink more, float, or taking time and sink. Now, anyone, maybe I came for a reason of gender, a lady also, or a woman, to remove the skin. But we have the other one, which was this one maybe was in water, and it was taken somewhere. Means you have to use a new one, which doesn't catch the water. For the third group, we see that not the water inside to make it to sink. You will remove it without. You can come here. Come and. These also, you can put them together. You help us to understand that.
By the way, do these things float or sink?
Float.
Okay. Anyway, they float.
You can stand up and say,
so now we have an orange which is made by something which is floating. Yeah, this can float. You want to say what that is floating? Then we are removing. Yeah. Why do they float?
like him, doesn't. Can you explain?
Yeah, he said, okay, good question. I could also use water, but I used just there is these things we have for Fanta powder. The powder, this Fanta, they have made some powder. And this one. Yeah. So this one I put it so that you can see what will happen clearly. Otherwise I could just also use the water. But for the water it will be difficult to do. Because in any case, what is important is to explain the reason of your answer. So now, observe it carefully. Look the level of the water.
Can you the level of the water?
Now,
it is one question. Another one, it means you have so many questions. Students, when you perform an experiment like this, students are excited and starting to ask so many questions. And from those different questions, we get a key question.
So there are two phenomena there. The kind of stop to writing, isn't it?
Yeah.
But you see also the level of the water comes up. So two phenomena we have to explain. Why is it
Oxygen inside the grass.
absent? But where the oxygen is going?
Oxygen inside the grass. So
Where the oxygen is going? Yeah, the oxygen was there. But where is it going? The oxygen was used in the phenomena of combustion. In that combustion, what is happening? Oxygen is being transformed into carbon dioxide. And the carbon dioxide is not really, it is not friendly to make it continue to shine. So now we have to think why the level of the water has rise. Yeah. Who is having an idea? Yes?
Before the candle switch off, inside the grass, the air was very hot, and the atmospheric pressure was more or less than outside atmospheric pressure. And when it switch off, the atmospheric pressure has obliged the water, cold water, to enter into the glass upward direction.
There are some ideas, but at least you can. There are some ideas you can do. When the candle stops to shine, right now, the air there becomes cold, isn't it? And even the pressure should be also reducing. The pressure should reduce. And do you agree on that? Yeah. But the pressure increases when the temperature has increased. So if the temperature is reducing, the pressure also should reduce. So then the pressure inside has reduced, but the pressure outside is still there. So there is a difference of pressure, which is pushing now the water to go. Yes, and this can give you an idea of saying the pressure we have here corresponds to the pressure inside plus saying the pressure we have here corresponds to the pressure inside plus rho G. You remember rho G H? Yeah. The pressure for this height of the liquid. And the total is the one which is going to be atmospheric pressure. Right? So we continue.
We were on this first experiment. Now we finish to remove the skin. Maybe you can watch. It means that what you observe, sink there. No, you can see here we have the water above. It is synced, it is inside the water. It doesn't take any time to stay here and catching the water in the sink. It is synced, it is very good. Now, let us ask you a question. The Prof was showing you that this skin, you can see, will float most. You can see this in real life situation. We have a such situation. Who can tell us that one? In real life, in the sea or lakes. When we are in the sea or lake, there is a jacket how to wear. It means before, this one was like a person like me, and this one was like that jacket, camouflaging it. It is why it was floating. It means when you are in the red or sea, in a boat, traveling, you have to wear life jacket. You see? Yes. And this you have to talk to the students and follow their raising their understanding why to wear always a jacket. It means this one is made by material which is heavier, or density of this one is heavier compared to this as persons. But when we wear something which is floating more, now this thing will be like a summation of the two, and you can float. Yeah. Maybe let us continue with another experiment.
Okay. For floating again, we have this scenario of eggs. And if you have it as it is fresh egg, and if you put it into the water, what will happen? Does it sink or does it float? Anyway, the next time is to say, as you are a scientist, you should measure the mass. You can measure the mass, and you can measure the volume. How do you measure the volume of an egg like this one? You put it in water, and when you see the volume, it has expressed. That one you know. So now, and then you calculate the density, and you compare the density of the water, and you say, if it is higher, it sinks. So that's what scientifically you should also do, but it sinks. It sinks. It goes down. There's no problem. However, the same water, if you put salt, this is the same water, but I have added some salt before. But this is what you are going to do. By putting salt, what am I doing on the property of this water? I am changing the density. Am I increasing or reducing it? Increasing. I am increasing it. So look now, look the egg. It is coming up. It is coming up. Stopped, and now it is now coming up. So the only property which is defining if something is sinking or floating is the comparison of the density between this object and the fluid in which you are putting it. So if the density of this is greater than the density of the liquid, it has to sink. So now there are many things you can see. You see, even a person, when you fall in the water or in a lake, you can sometimes go. If you don't know how to navigate, you go down. Why you go down? The density of the whole body is greater than the density of the water, because we are made with water, yes, but we are made also with minerals, some salt minerals. In the way, as long as you are going down, you are sinking down, and you spend there some time, those salt minerals, they are going out. And then you remain with something which is not really dense, and then after some days you rise up. That's what's happening. So that's what I was also worried, because people are saying water is internet. Water can enter, but also some sugar inside can also go out due to the osmosis. So there is a part which is entering, there is another part which is going. That's why you have to be careful. That's why what he did, it was a little bit good to remove the peel and show that it is going directly without waiting that phenomena of water entering and whatever happens, so that it can influence the results. So that it is going directly down in the water. Okay, another experiment.
Yeah, we have so many, maybe in Asia also. I think it is
okay. So, one of the type of experiment you will be obliged to do will be to demonstrate some scientific laws. So, the one we are going to demonstrate is just the law of inertia. In physics, inertia is the tendency to resist to the motion. It's a natural phenomenon. We didn't buy from anywhere. It's just when you have a certain mass, you have that tendency. So it's for everybody. Actually, it's not even to the tendency to change to the motion. Even it's just a tendency to resist to the change. Even in the real things, when we change the rules, if the government change the rules, even when we say, everyone should be vaccinated, the people have some resistance to change, to go to the vaccination. And if we say CBC has changed, some teachers are still going to teach in a usual way, but we change it. So there is always such a resistance. So the law of inertia, you can really say that if you put a coil like this one, and when you want to, it is here, there is no problem, it is sitting there. So if there is no other force, you remain there. That is the first law as well. If there is no external force, the thing stays at rest. However, if I want also to put it in motion, the coil wants to remain. So remember, this law is such important so that you have to teach it to the students, because the one which is causing the accident. So the driver is going and see there is an obstacle. He wants to stop, but when he stops, the guy who are behind very wanted to continue to move, and that's where they pass through windows. But if you manage to stay fixed, there will be no problem. You stay where you are. But once you pass through the window, but because it causes problem, and it comes for the people who are heavier than others. It means kids are not affected too much. During the accident, some kids can survive. But the people who are heavy, those are the ones who are going to pass through windows and so on, because the inertia or that resistance is proportional to the mass. Isn't it? So these are the type of experiment you come in the class and you demonstrate, and the students see how the law is being demonstrated, and then you continue your switch. Another experiment.
And when you are, I can complement to this.
Yes.
When you are demonstrating this, explaining this inertia law, you have also to come up with the third type of the objective. You have a knowledge, skills, and value. For value, it means you have to tell to your student that when you are in a car or airplane or in a boat, you have to wear the seating belt properly. You have to wear it properly, not cheating to make it where you are serving the policeman, but you have to make it because to serve your life. Because when the accident will come, you will be wanting to move, but this belt will take you to the same position. Yeah. It was that I wanted to add.
So another experiment, I think. Okay, this one. So this is a balloon. There are also other balloons which are empty, where I can find them. But if you have a such balloon which is empty, and if you put it on fire, what do you expect? If you put a balloon on a fire,
it means we have a balloon, and inside we fill it with water.
I want to start with the one with no water. The one. Yeah. I'm missing it. But I think you may have seen it. If you take the candle and you put it on a balloon which is filled with air, what will happen?
Have a candle, maybe this one.
The part which was destroyed. So if you fetch a balloon and you blow there the air, it will inflate. But if you put the candle in, it will expand and it will be blown out. So, but surprisingly, if you put water is inside, and then you take your candle, in the grass.
Smash it.
So, if you, okay. So if there was no water, if there was no water, it should have burnt. But now you can see it is not easy. So, it's going to die. So, as you can see, it is really not producing any effect, isn't it? It's not producing any effect. You see? So now, this is what we are asking you to do. If you want to produce future scientists, expose them to these observations. And then, from observations, they start to question why. From those questions of why, we have to find some answers. And that's where we will be knowing that students will be learning. Who can tell us why is it not burning it? Why the balloon is not being burnt? Who can explain the reason? If the balloon was empty, once you put the water, it will burn. Isn't it? So, but once there is water, it is not burning. What is the reason?
Yeah, I think it is because inside the barrel there is water, and this, I know that the heat must flow from the fire to the barrel in order the barrel to be burnt. But when there is the water inside, this heat, the heat required to raise the temperature of water must be higher. And the water must be have temperature required to burn this barrel. But the temperature of water is lower to burn the barrel. I think it is because
the temperature which is here is very, very high. Very, very high. Some hundred of degrees, it's not 100, it's 1,000 here on the frame, which is almost blue. It is really too much. So, let's go quickly. We say that it's not burning because the heat, in order to be burnt, what is happening naturally? Your body or the material should accept that heat. And the heat is accumulated at some place. If it is accumulated, atoms and molecules which are there vibrate quickly. Vibrate quickly, and they even go out from their orbits. And that atom, when it is destroyed, that is the destruction of everything, isn't it? So now here, what is happening is the small balloon is too small, so the heat is not able to accumulate inside. It is going transmitted directly to the water. No time to accumulate inside the balloon. It's going to the water, and even the water is the one to change the temperature and breathe. That should be the reason. So there are, on the website, I think in the manual, we should have put where you can put different experiences you are going to use in this as discrete event, which can help really you to engage your learner or to excite them so that they can think during your lesson. Think towards solving the key question. So we have, you are lucky because when I was, you destroyed my stuff. So anyway, this is what we call lemon. Lemon, what is it? Indium. So this lemon, inside there is an acid. Some people say acid is always bad, but we are eating it. We eat acid. So, and then, when you have an acid, it's already an electrolyte. So it can conduct the current. Or, and this guy is copper, and the other one is zinc. So when they react differently to the acid inside, I think the guys who do chemistry, they may realize they can go deep and talk about oxido-reduction reactions. I think you know, but maybe you are not expert because you are not chemist. But others, they should interpret it as those type of reactions, which will create a potential difference between this electrode and the other electrode. So what is important to figure out is that when you have this, it's like a battery, it's like a cell. So how to prove it is take your multimeter and then measure, isn't it? So we should be measuring the potential difference between zinc and aluminium. That is we go and then you. So you can see it is starting to measure almost around 300 millivolt. If it is 300 millivolt, 300 millivolt. So here it's for measuring the volt. So it element is indicating negative. It means I have inverted the boundary. So you see, it is having even the positive and the negative. If we change, it indicates you that you have already yes. So this always is positive and this is always negative. I said this is copper, this is zinc. So you can you can even put them in series. So when we put things in series, the positive and the negative are joined together, and you have now another cell, a chemical cell. So again, if I connect, so you can see the voltage now increases. Can you see? The voltage increases, but it's negative. So the positive should be here on the copper, and the zinc becomes negative. So you can see it has really connected. So meaning that don't always complain that you don't have materials. Because these laws are for the nature. And the nature we have. Probably what you need is an instrument like this intimate, and you can see it stabilize around 500. You can see. So this is a demonstration showing that we have now electricity from the lemon. It's good. And now our kids are clever. They will start to search why. Unless you don't really excite them. Once you have excited them, they will at the end know why. Asking you questions. Why? And then this is what you find, but in modern things, the batteries we are having them. So if you have a battery, how do you measure the voltage? How do you measure the voltage? Positive and then negative. But in one of the mode of experimenting, you have to teach people how to use instrument. Because if you don't know how to use instrument, you will not be able to get the measurements. So the positive goes to this range, and the negative goes to what we call ohm. And then you have your systems. And then if you want to measure for the battery, the positive goes to the battery, and then to the negative. You can see it's stabilizing at 5 and 3 sides. You can also measure this one. Measure this one. Okay. Positive and positive, negative to the negative. Positive to positive and negative to negative. Positive, do it. Positive, negative. Positive and negative. Negative and positive. So you can see now it is going to 11.34. Remember we have 6. Someone was having 5. So addition. So after all, the student will not say because it has been now time now to connect to the lamp. Can you connect to the lamp? You have the batteries, you have the lamp. How do you connect them? The lamp doesn't. Now this one is having polarity because it's a red lamp. So it has positive, it has negative. So put positive. Don't be afraid. 12 volts cannot change. Even 200 volts. Don't be afraid. Good. So we have our lamp now going a little bit much higher, isn't it? So this is a good thing. With one, you can't, because it is needing 12, so you can't really put it there. Actually connect it to this one. If we connect it to one kind of but this one it cannot light because it needs 12. Yeah. So if it needs 12, we put 6. Say no, I cannot. But we need to. It has its 12 volts. So I think this is the second the first science experiment where you can develop an inquiry in very go check the laws, investigate, ask questions, change what's different to this, you allow them to you see what they are taking in. You continue the interpretations and we are together. So that's there I say many batteries there. Practical work. Why do we need practical work in class? How do we need to conduct practical work in class? Why do we need to conduct the experiments? Yes. Okay.
They can use their practice in everything that they
We don't want to teach people in theory. This is practice. To connect the theory to the reality. Connect the theory to the reality. Until the student comes here and touch. That's why I understand much more on his own. Otherwise, he may be having some misinterpretation or misunderstanding, or somewhere else in him some alternative ideas, misconceptions. So unless you prove him that what you want, what you are thinking is not the correct, this is how it works. That's how you are going to change it. Okay? So, what next?
Yeah, there was even for potato.
Yeah, the potato, I brought it as well. It's not like a chemical cell. There is no acid. But yesterday when I was doing it, when you connect to a potato, you will observe that here there are more reactions than here. So some people are talking about a battery from potato, but the potential is not really strong there. But you can notice that if you, here there are some reactions, and here there are no reactions. So meaning that we can see a potential difference between the two, but small. So next time, I'm going to analyze this and by what we call a lead. Lead is, imagine, if I could bring a lamp, a small lamp like this one, and connect to this and very shine. That's why you notice that, oh, there is electricity. But another way of doing it, to bring a multimeter, and when you see that, there is electricity. That's another way around. But to show it better, we have to use the lead. We have to calculate it in the program.
Yeah. Hello everyone. We went through different equipment. Maybe let us we continue after. Some said that our schools don't have equipment, but we have also to try. This one, this 7, one is with bigger size, another is with small size. I connected together and I show differently. I can even find another small tube to get a connection, and that I will have what we call hydraulic press. You understand? If I push here, you will need a certain force greater to when I use this side. Anyone to verify? And the law of the formula is there. Here we have small surface, and we should have yes. We have a force which is equal to the pressure is equal to the force over the surface. Pressure in a force to the surface. The force in na pressure that is the surface. See? No. When we have small surface here, the force we were able to fit the same forces. Now the same pressure inside. Here we should have a small force, and here we should have big force. Yeah, the equation you can. Yeah, he's writing there.
Okay, so you have the same thing, but we are inverting. It means if I could connect with another thing, I can just have this like this, and then connect them in the way we are seeing it. So then you know that the section number on this, the section here. Okay. So the force on the surface A is just, the pressure is this. And then here we have also the section B, and there is another force which have to be here. So the pressure B should be force on B, and then SB. So now it turns out that there is a law which we are calling Pascal's principle, which is saying that the pressure is transmitted integrally in all directions. So it means if you act here as a pressure, the pressure will go to be transmitted here. So definitely that's Pascal's principle will be saying that pressure on A is pressure on B. Therefore, there is a pressure FB here, FB here, which is FB. No, the pressure they are equal. So I'm saying if A over SA is equal to FB over SB, so we can see that FB is equal to SB over SA multiplied by FA. So because SB is greater than SA, so you can see that FB is greater than FA. So what is this? It means you act with a simple, like he was saying, you press with a simple force. But you then hear a big force. So you can exploit this scenario and put, let's say, a car, and then you lift it with a bigger, because it is having a heavy weight. So you can now push here, you push, and then the car is lifted up. So what we call hydraulic lift. So that's a simple principle to show using syringes, and it's not even costing a lot. Okay. So the other one is like let me try on this. So we have now equilibrium is difficult to lay, but it's the same principle. So you have your name, and when you start, if you, okay, so if there was no water, if there was no water, it should have band. But now you can see it is not the other, and then this one, and then the other, and then this one, probably I can give, and then the other. So the remaining one, I can just invert